Welcome to Alpha Numeric Tricks. In this video, we are going to see the problems under the topic first order nonlinear partial differential equations. In last video, we have seen that how to get the solution of type 3 case 3 problems, that is how to get the solution of those type of problems. The link is available in the description box. If you want, please have a look on it. Now we are going to see how to get the solution of the problems of the type 4 separable equations, that is of the form f of x comma p is equal to phi of y comma q. Now we will see how to get the solution of these two problems one by one. First we will see how to get the solution of p squared plus q squared is equal to x plus y. Take the given problem as equation 1. After numbering that, we have to identify the problem. That is very important. Problem type is very important. Once you identify the problem type, we can easily get the solution using predefined procedures. Okay. And now in this problem, P, Q, X, Y, 4 terms only present. So here in all the 4 types, this type 4 is of the form X, P, X, Y, P, Q, all the 4 terms present. So we can, and also it is separable. So we can conclude that this is of the type 4 problem. So the problem is asked to find out the solve the problem. So you have to find out complete integral, singular integral and the general integral. And what is the procedure for finding type 4 problem? Just we recollect that. How will you get the complete integral for this type of problem, type 4 problem? After separating x terms together and y terms together, you have to equate that term to be some constant, and each is equated to that constant, and using that we have to find out the values of p and q, and those values are substituted in dz is equal to p dx plus q dy, and integrating we can get the complete integral or complete solution. And then the singular and the general integrals are as usual like your previous types. Okay. Now we will see how to get the solution of this problem. First you have to find out the complete integral. As usual, we have to write the problem as of the type separable equation f of x comma p is equal to phi of y comma q. After that, we have to separate the terms, that is x terms together and y terms together, and equate that to constant. Here p squared and x are same because p is dou z by dou x. So this is related with x. So p and x are combined together and q and y are combined together. So when you're taking x to this side, it becomes minus x, and when you're taking q squared to right hand side, it becomes minus q squared. So we have p squared minus x is equal to y minus q squared, and which is equated to some constant a. After that, we have to equate each term is equal to that constant a, and then what is next? We have to find out the values of p and q. How it is possible? You have to get the values of p, that is taking p1, okay, keeping p one side and other variables to remaining variables to your right hand side. Then we have p squared here from this equation. P squared is equal to minus x is taken to right hand side, it becomes plus x. So a plus x we have. Similarly, here q squared we have to find it out. So when you're taking q squared to other side, it becomes plus q squared, and a to your left hand side y minus a we have. So q squared is equal to y minus a. When you're taking square root on both sides, you get the values of p and q, that is p is root of a plus x and q is root of y minus a. And now these values of p and q are substituted in where? In the equation, dz is equal to p dx plus q dy. Substitute it now. Dz is equal to root of a plus x dx plus q value is root of y minus a dy. Now we have to integrate this equation. So we have integral dz is equal to integral of root of a plus x dx plus integral of root of y minus a dy. We have to integrate this term. What is integration of x power n formula? formula for integration of x power n is x power n plus 1 by n plus 1. The same idea or same formulas used here also. Instead of x power n, that is n is a whole number there. Here we have a fraction because a square root is there. So square root is half, we can take it. So a plus x whole power half, we can take it here. Okay. So we had to using that is taking a root of a plus x as a plus x whole power half. We have to apply the formula, that is a plus x whole power half plus 1 divided by half plus 1 plus integral of root of y minus a is y minus a whole power half, we can take it. So y minus a whole power half plus 1 by half plus 1 plus this constant of integration c, and integral dz is z, you know that already we written. Okay, so how will you write this? What is the half plus 1, which is 3 by 2, and this denominator also you have half plus 1 divided by 3 by 2 you have, and you have to take the 2 to numerator, so it becomes 2 by 3. 3 by 2 becomes 2 by 3 into this a plus x whole power 3 by 2 plus here also you have 3 by 2 is in the denominator, so you have a 2 by 3 into y minus a whole power 3 by 2 plus a constant. So we have this term z is equal to 2 by 3 a plus x whole power 3 by 2 plus 2 by 3 y minus a whole power 3 by 2 plus a constant. Now you have to number that equation as 2, which is our required complete integral. Now we have to find out the singular integral. Singular integral is as usual manner. What is the procedure? You have to differentiate this complete integral partially with respect to the available arbitrary constants. What are the constants available here? A and C. So you have to differentiate this partially with respect to A and C, and you have to use the rule dou z by dou A is equal to 0 and dou z by dou Z is equal to 0. Here also you have to use the available constant. A and C is present here, so use it A and C. If A and B are present, you have to use it A and B alone. Okay. Now, after this, you have to eliminate A and C. You can get the singular integral. But one thing you should keep a note on it. Here, whenever your arbitrary constants are separately present, any one of the arbitrary constant is separately present, then you have to differentiate that term, that equation with respect to that constant first. Then using that you can easily conclude your singular integral. Okay, if in such cases no need to go for this lengthy differentiation. Okay, so we try to differentiate this. So differentiating this equation to partially with respect to C, because C is separately there. Whenever you have this type of solution, complete integral, then you have to differentiate this first. Okay, then you can easily conclude your result. That's why I ask you to do that. Okay, now what is differentiation of z with respect to c? Dou z by dou c, so which is equated to 0 using this rule. So 0 is equal to, this is constant differentiation, because it is differentiation is with respect to c. Here there is no c term is present, so which is the constant differentiation becomes 0. Similarly for this term also, this is also 0 plus differentiation of c with respect to c is 1. So 0 is equal to 1, which is an absurd result or impossible result. We got it. So we can conclude that with using this we can't find anything. So we can conclude that there is no singular integral for the given problem. Now we have to find out the general integral. General integral is also usual manner we have to find it out. That is, you have to reduce the two arbitrary constant in the complete integral to single arbitrary constant with the help of the substitution c is equal to phi of a. How you get the substitution is even one arbitrary constant in the complete integral is written as the function of the other. Here either you can use c is equal to phi of a, or you can use a is equal to phi of c. Both ways it is possible. This is substituted in equation 2, that is a complete integral. Then here it becomes that is single it is two arbitrary constant in the complete integral is reduced to single arbitrary constant because of this substitution. Here rest of the things are as it is, only we have to go for c. C is a substitution phi of a, so we have substituting c is equal to phi of a here, and rest of the things are as usual, like a complete integral we have to write it because there is no c there. Number the equation as 3, and after that you have to differentiate this equation 3 partially with respect to that constant a. Here instead of we are substituting a is equal to phi of c, then your z becomes the function of c alone. In that case you have to differentiate this with respect to c. Okay, but here we are substituting c is equal to phi of a, so equation is in terms of a, we are differentiating with respect to a. That is the idea. Okay, so differentiating this, dou z by dou a is equal to 0 as usual. Using this condition or rule is equal to 2 by 3 you have to write as it is, and differentiation of a plus x whole power 3 by 2. Here we have to apply the formula x power n differentiation. What is differentiation of x power n? N into x power n minus 1. So here in the place of n you have 3 by 2. So we have to write it 3 by 2 into a plus x whole power 3 by 2 minus 1. What is 3 by 2 minus 1? Which is half. That is written here. That's all. Okay. Plus 2 by 3 into, here also we have to apply the same formula because we are differentiating this with respect to a. Here a is present, that's why. So x power n formula we have to apply it. N here is 3 by 2. So 3 by 2 into y minus a, in the place of x you have y minus a. So y minus a whole power 3 by 2 minus 1, that is 3 by 2 minus 1 is half, into, you have to differentiate this y minus a partially with respect to a. Differentiation of y with respect to a is 0 because it is constant. Y is a constant when you differentiating with respect to a. Minus differentiation of a with respect to a is 1, so that's why we have minus 1 is written here, plus differentiation of phi of a with respect to a is phi dashed of a. That's all. You have to conclude your result. No need to simplify further because we doesn't know the function phi of a. That's why we conclude your result like this. Okay. That is, after you simplify this, that is 3 get cancelled, 2 get cancelled. So root of a plus x minus root of y minus a plus phi dash of a is present. So number that equation as 4. After that we can conclude the answer because no need to simplify this phi of a and all because we doesn't know the term. That is, we no need to eliminate this a because we doesn't know phi of a. That is the reason. Okay. Now we conclude that eliminating a between 3 and 4, we can get the general integral. That's all. This is the solution. This is the way we have to write the solution for this type of problem. Now we will say one more problem. Find the complete integral of p squared plus q squared is equal to x squared plus y squared. In our problem, make a note of it. We just find out the complete integral alone. No need to find singular and general integrals. Okay. So for that is here, first we have to number the given problem as equation 1 and you have to identify the problem type, that is p, q, x, y is present. So which is type 4 separable equations. So we have to write the solution. Complete integral you have to write it. Before writing that, this is of the form separable equations that you have to write it. That makes your solution, that is your answer, very clarity in your answer. That's why I ask you to write this. Okay, this is separable equation. F of x comma p is equal to phi of y comma q. Now we have to make use of the substitution for this. At first you have to separate the terms, that is x terms and y terms are separated. So here you have to take x square to left hand side and q square to right hand side. When you're taking x square to left hand side, it becomes minus x square. So you have p square minus x square is equal to, when you're taking q square to other side, that is the right hand side, you have minus q square. So you have y square minus q square, which is equated to the constant a square because both the terms are here in these two equations are these two terms. Both the terms are square. Power square is there. So when you're writing this is also square, then your simplification becomes easy. That is the only purpose we are using this constant a square instead of a. Okay. Now we have to separate these two terms, that is equate both the terms to a square. So p square minus a square, p square minus x square is equal to a square and y square minus q square is equal to a square. Now we have to get the values for p and q. That is, first you have to find out p square. Keep p square to one side and remaining terms to other side. So when you're taking minus x square to the right hand side, it becomes plus x square. So we have p square is equal to a square plus x square. And in the same way, you have to take that q square to other side. That is, it becomes minus q square is there. So when you're taking this side, it becomes plus q square, and you have to take that a square to the side, it becomes minus a square. So you have y square minus a square is there, which is equal to q square. Now we have to find out the values of which value? Yes, p and q. For that we have to take the square root. So p is equal to root of a square plus x square. Similarly, q is equal to square root of y square minus a square. That is substituted in dz is equal to p dx plus q dy. Substituting, dz is equal to root of a square plus x square dx plus root of y square minus a square dy. Now you have to integrate this. Integral of dz is equal to integral of root of a square plus x square dx plus integral root of y square minus a square dy. Here what is the integration of this? This is a standard integral formula. You are already familiar with that. If you are not remember, you have to remember this equation. Okay, you have to remember the solution of these type of integrals. Integral formula you have to remember. Integral dz is z, and integration of root of a square plus x square dx is x by 2 into root of a square plus x square plus a square by 2 sin h inverse of x by a. This is the formula for this term alone, first integral alone. And the integral for second integral is y by 2 into root of y square minus a square minus a square by 2 cos h inverse of y by a plus a constant of integration, which is our required complete integral. Okay, now here problem is asked to find out complete integral alone, so we stop our problem here itself. Okay, that's all for this video. If you have any doubts in this, please provide in the comment section. Thanks for watching. Keep watching our YouTube channel Alpha Numeric Tricks for more videos. Thank you.